file is all from the video that I asked you guys to watch at some point over the weekend, and it's just over basics of matrices, okay? So when we talk about the dimensions of a matrix or an order of a matrix, we do it by the number of rows times the number of columns. So like in here, we've got, so rows again are left and right, columns are up and down. So we've got 2 rows by 3 columns, which becomes really important when we get into multiplying matrices as well too, okay? And then when we denote like elements of a matrix, we do it based on the row is listed first and then the column is second. So it's always left and right, from left to right and top to bottom is a common theme that we will use while we talk through matrices, okay? And then when you set 2 matrices equal to each other, they have to have the same dimensions in order for us to set them equal to each other. And then we set the corresponding elements equal to each other, okay? So when we did this example, we just set like x plus 4 equal to 3, set up a little mini equation and then solve it. So then we did that for each one of our elements of our matrix, okay? And then same thing here, it says solve the equation for each variable. So we would set y equal to 3x minus 2. This is a 2 by 1 matrix, and then equal to a 2 by 1 matrix. We can do that. We can set those things equal to each other. This one, I think we ended up solving by using substitution, okay? All right, and then on this slide, this is about the only one that would be a little more difficult, okay? When we add matrices together, same thing, they have to have the same dimensions, and you just add each one of the corresponding elements together. So both of these matrices are 3 by 3. So then we would just set, we would just add each one of the corresponding elements together to end up with our new matrix that represents a plus b, which would also be a 3 by 3 matrix, okay? When you do 3 times a matrix or a scalar multiple times a matrix, you literally take that value and multiply each entry or each element in that matrix by that value, and that'll give you what your new matrix is. And then when you, for this one, we would multiply 3 by a, get a new matrix, which is what we would write here. And then we would subtract the elements from b from the entries in that matrix, and then we would get a new 3 by 3 matrix here, okay? All right, now let's talk about A transpose. So it looks like an exponent of T, but when we find A transpose, what we are doing is you're interchanging your rows and columns. So you're swapping your rows for your columns. So your rows become your columns. So A transpose would look something like this. So here is my matrix for A here. All right, so my row 1, 3, negative 5 would be my first row. That will then become my first column. So 1, 3, negative 5, okay? And then my second row would become my next column. So negative 4, 5, and then 0. And then same thing with my last row. So 4, negative 8, and 9 would be my final column. Now, when I find the transpose, what does that do to the dimensions of my matrix? In this case, the 3 by 3 stayed as the 3 by 3, right? However, what if I had like a 2 by 3? What would the resulting transpose be? It'd be a 3 by 2, right? Because I got to take those elements and then I got to list them in another way, which would then change the dimensions of my matrix or my matrix if they were not initially the same. Okay? All right, that's basics of matrices. All stuff you guys did last year, right? Okay, I'm excited because this is the first time I've ever taught matrices in my career. So that's exciting for me. Strange thing to get excited about, but either way. Okay, let's do 4.2. All right, so all the basics of, oh wait, this is section 4.2 in geometry. Hey, we're on the same section in geometry. You guys don't want to do those though, do you? It's a bunch of stuff with triangles. AP Calc, not there yet. See you next year. All right, 4.2. Today we're going to spend our day talking about multiplying matrices together, another concept that I believe you guys have seen in the past. So hopefully this will be a decent reminder for you. Now, you'll start to see some of our digital resources listed. So there is an IXL. I know you guys love IXL. There's an IXL assignment that's worked out there. If you want more practice multiplying matrices, you can go to that. And then you guys know the drill with IXL. They kind of help you out and guide you along with solutions. So if you're looking for some enrichment, some extra practice, some extra help, then IXL will help you out. Okay, I'm not going to take it for a grade, but that's another place that you can get, do a couple problems and get into the swing of things in order to, answer some of these. Okay. All right, so you can multiply two matrices by each other if and only if the number of what in the first matrix has to match the number of what in the second matrix. Do you guys remember? Hannah? I thought you were raising your hand. Do you guys remember what those are, though? Rows, right? So the number of rows in the first matrix has to match, wait, actually that's opposite, right? Yeah, it should be columns and rows. Because what has to be the same is my inner dimensions. So the number of columns in my first matrix has to match the number of rows in my second matrix. So your inner products have to be the same, okay? So for example, if I have a matrix that's a 3 by 4, I can multiply it by a matrix that's 4 by 2 because my columns match my rows. Columns of my first match the rows of my second, okay? And then the resulting matrix, the dimensions of the resulting matrix, is the outer product of my initial matrice, okay? So in this case, we would say that our resulting matrix would be a 3 by 2 system, okay? You guys probably remember, but what a matrix is allows us to set up basically a system of equations, okay? All right, so let's do a little practice there. So can I multiply these matrices by each other? And if so, what would be the dimensions of the resulting matrix, okay? So can I do m times n? I got a 2 by 3 by a 3 by 8. I can, right? What would the resulting matrix be? 2 by 8, good. So these match. So yes, smiley face. All right, and then for the middle one, we have a 3 by 1 multiplied by a 1 by 4. Can I multiply those? Sure can. What's the resulting dimensions? Very good. Okay, last but not least, can I do a 3 by 1 by a 2 by 5? No. My inner dimensions do not match. Not possible. All right, cool. Questions there? Hopefully a bit of a review. All right, now the way that we've worked out like these examples is we gave you like a nice space to find all of your values. But in reality, when you guys work through your homework on these, you're kind of going to have to set this up yourself, okay? All right, so we want to find KL, for K is that given matrix and L is that other given matrix. So what are the dimensions of K? 3 by 2, 3 rows by 2 columns, left to right, top to bottom, okay? And then L would be what? 2 by 3. Kind of gives you a bit of a hint down below, but the dimensions of my resulting matrix, K by L, would be what? 3 by 3. Okay. So now comes in the part where I actually do the multiplication. Okay? All right. So in my first cell, essentially what I'm going to do is, again, I do left to right, top to bottom. So I need to focus on the first row in my first matrix, at least the matrix that's listed first, the K in this case, and then I need to interact with the entries in my first column for my second matrix. Does anybody remember what I do with those numbers? You multiply what? No, you're right. What do I multiply? 1 with the -3. Yeah, and then separately, the -2 with the -1, right? And then what do I do to those values? You add them together. So it's the sum of the products. So I'm going to do 1 times -3. So 1 here, -3 here, plus -2 times -1. Which gives me what? -1, because that would be -3 plus 2, which would give me -1. And that's my resulting entry. Okay? All right. Now, let's do my space along the top for number 2. Okay? So here's what I'm going to do. I'm going to use the magic of technology here. Since this is still the top row, I'm not going to move... What? I'm not going to move like this part at all. I'm going to leave that where it's at. Okay? Instead, now that I'm in the second column, I'm going to take this and I'm just going to... Can't really do nothing with it. I'm going to take this and I'm going to move it right over here. I'm going to focus on those values. I'm going to repeat the algorithm. Okay? All right, so then I need to take 1 times 2 and add it to -2 times -2. Okay? All right, so 1 times 2 is going to give me 2. -2 times -2 is going to give me +4. 2 plus 4 is going to give me 6. All right. Let's get my entry for the top right. I'm keeping the top row the same, but I do need to adjust my column. So let's take my marker, move it over here, and then do those values. Okay? All right, 1 times 2 plus -2 times 0. Oh, man, you got to love when you get a 0 in there, right? Which is going to give me 2. All right. Feeling okay? Sum of the products is what we're doing. All right, let's move some things around. Now we're doing the second row. So I'm going to go back to my matrix for K, and I'm going to move that down to my second row. And then let's take that value and move it to the left. Okay? All right. And then we do it all over again. So 4 times -3 plus 3 times -1. So that would give me -12 minus 3, which is -15. You guys will find that we'll probably start doing this a little faster, I think. Okay, what happens if I do this? If I do this and then I do that? Yeah, there we go. Okay. All right. So let's do our second row, second column. So then that would be 4 times 2 plus 3 times -2. All right, so then 8 minus 6 would give me 2. And then let's focus on my last value. Okay, so then 4 times 2, which is 8, plus 3 times 0, which is 0. So 8 plus 0 is going to give me 8. Okay? I'm going to go a little faster now. Are we okay with that? Are we ready for me to go faster? Okay. All right. So let's move these over. It's like a Ouija board. Okay. So 0 times -3 is 0, plus -1 times -1 is going to give me +1. So I'm going to have 1 that goes there. Okay. And then I would do, slide this over. 0 times 2 is going to give me 0, plus -1 times -2 is going to give me 2. So 2 along the bottom. And then if I move that last value over, I would get 0 times 2, which is going to give me 0, plus -1 times 0, which is 0, so I get a 0 there. Tedious and a bit annoying, truthfully, but that's how we multiply our matrices. Okay? Questions there? We remember this from last year? Quite a process. Super. All right, cool. Let's do more examples. All right. Now we want to find L times K, for K being the same matrix and then L being the same matrix. So same thing, okay? Same matrices that we're starting with, but now in this case we want to find L times K. All right, so again, the dimensions of K are 3 by 2, right? 3 rows, 2 columns. And then the dimensions of L are going to be 2 by 3. My inner matrices would match. However, remember, we're doing L times K. So I need to do really a 2 by 3 multiplied by a 3 by 2. Okay, so this would be representative of L. This would be representative of K. My inner matrices match. That's good. So then my resulting matrix is going to be a 2 by 2. Okay, which means we will add more values together when I do this multiplication. All right. Okay, so let's do this. So we want to do, in this case, we would do left to right times top to bottom, but the left to right that I'm going to do is going to be in L, and the top to bottom I'm going to do is going to be in K, because I'm doing L times K. So it's different. So we, based on how we had our information, we're doing things a little differently this time, so we just got to be careful with that, okay? But still, I multiply all those corresponding elements by each other, okay? So, all right, so I would do -3 times 1 plus 2 times 4 plus 2 times 0. All right, so -3 plus 8 is going to give me 5, plus 2 is going to give me 7. All right, and now I want still my top row, but my second column. Did I mess something up?
I don't think it's 7, it's just 5.
Oh, it's just 5, isn't it? Where did I get 7 from? I don't know. It's just 5. -3 plus 8. Oh, and then I added 2. I didn't think about the 2 times 0. Womp, womp. All right, 5. All right, I apologize. Okay, so I'm staying in the top row, but I'm now moving to the second column. So I'm going to change this marker over here and then multiply those corresponding values by each other. All right, so when I do that, -3 times -2, which gives me 6, plus 2 times 3, which gives me 6, and then plus 2 times -1, which would be -2. All right, 6 and 6 is 12, -2 is going to give me 10. All right. Now I'm moving down to the southern part of my resulting matrix. So then in that case, let's see, bottom left. So I need to move this here and then move my marker down here to the bottom and then multiply those together. All right, 1 times -1, and then 4 times -2, and then 0 times 0. All right, so then -1 minus 8 is going to give me -9. And then last but not least, we need the bottom right. So I need to move my column over to the right column, still on the bottom. So 2 times -2 times -1 is going to give me 2, plus 3 times -2 is going to give me -6, plus -1 times 0 is going to give me 0. So I would get -4. Did I make another mistake?
No, it's good.
Okay. It's not fun. This is not the most riveting lecture I'm going to deliver to you guys. It's simply not. So, all right. Notice when you multiply K times L, you don't get the same thing as when you multiply L times K. So because of that, what property is that called when you can do it in either order? Do you remember? Commutative. So the commutative property does not hold for matrix multiplication. I don't know, I tried to think of ways to like jazz this lecture up, but other than just playing jazz, like I don't think I can do it. I don't think, what'd you say? A game? You could count the number of times I say and then I have to curve your next test by that many points. I don't think I say that a lot though, do I? I don't know if I do. Okay, fine. As if teaching you guys honors pre-calculus isn't difficult enough, we'll add that element into there as well too. Hey, this is a practical application problem. That's interesting. Okay. Machine 1 and 2 produce shirts, hats, and pants at the hourly rate given in matrix H. Matrix D gives the number of hours each machine runs during the week. Did I say it already? No. Okay, thank God. All right. Okay. Oh, no, I did it, didn't I? Dang it. What? Okay. I can do it. We can do it. We got it. Huh? Does not count.
How do you say without the H?
Stop it. Shoot. That was an doesn't count. Correct? Dude, I'm just getting stressed out. Okay, here we go. Matrix C gives the number of hours each machine runs during the week. Okay, so we've got H and we've got matrix D. H tells you, does it? Shoot, I can't do this. I can't. You guys are gonna get 100% by the end of the period. I'm stressing out. Okay, what does the 3 mean in matrix H? Okay, so again, that gives you the hourly rate that it produces these items. Oh, brother. Okay, so what does the 3 mean in matrix H? What do you guys think? Michael, please.
It's the amount of shirts by machine 1 in 1 hour.
Yeah, so the rate at which it produces those shirts, okay? So it gives you the rate at which machine 1 produces shirts in 1 hour. Oh no, I did the thing, or I didn't do the thing. I'm so sorry. Listen, I got so you know what? There's no excuse. There's no excuse. All right. All right, what does the 4 mean in matrix H? So we've got a 4. It looks like it's underneath the column for 2 with hats. What does that mean? So it's the rate at which machine 2 can produce hats in 1 hour, right? Good. So the rate. I was just so ready to talk about matrices today. I forgot. Machine 2 produces. What are we doing? Hats? Okay. Would you believe me if I told you I took attendance in every other class today? You guys are smart. I did, though. I didn't forget. Okay. All right. What does the 12 mean in matrix D? So that one's actually in matrix D. We moved to the other matrix. What did that matrix tell us again? So it's the amount of hours that what? Good. So it's the amount of hours that machine 2 runs on Wednesday. So the number of hours machine 2 runs on Wednesday. You go back to the crayon. I like the crayon better. We're just missing Miss Harper. Okay. All right. Which one is defined? Matrix H times D or D times H? Then we want to find the product and state what the element of 36 means. This is going to take some work. It's going to take some work. All right, so let's look at the elements of my matrix here, or the dimensions of my matrix. What is H? 3 by 2? What is D?
2 by 5.
Okay. Can I do H times D? Can I do D times H? No. If I flip them, those inner dimensions will not match each other. So that means I can do H times D. So that's what I want to do, is I now want to find what H times D is. Okay? All right. So left to right, top to bottom. Let's do it. What will my resulting matrix be? Oh my gosh, that's a big matrix. All right. Oh, we can do it. I believe in you guys. No, stop. Now, I'm not going to show like all the work because I think we were to the point now where we can do the thing. Okay. So my resulting is going to be a 3 by 5. Okay. So I'm going to start by the first spot. All right. So we're going to do 3 times 8 plus 2 times 6. We'll show it. 24 plus, you guys are better at mental math than I am. 12. It is 36. Very true.
Thank you, guys.
So now we want to do, let's do top, but then we'll do the second column. All right. So then now, let's see. Nope, this guy. Boom. There we go. Okay. All right. 3 by 8 plus 2 by 10. What is it? 44? Okay. We're going to say this is 36 because Emmett is smart. We're just going to do that. Okay, cool. So then let's change our column for the next one. Okay, cool. So 3 by 8 plus 2 by 12. What do we get? 48? Is that what you said?
Yeah.
So 24 plus 20. Yeah, it's 48. Okay, cool. I know, I've got to check myself, honestly. I'm just requiring you guys to do it. All right, 3 times 7, 21, plus 2 times 11, 21 plus 22. 43. I swear if 67 comes up, I'm going to lose my mind, but not in a good way. All right, 3 by 7 plus 2 times 9. 21 plus 18. 39? Okay. All right, we do have to do 3 rows here, so I didn't really leave myself a ton of room, but we can do it. Okay, now slide that down to the middle, slide this down to the front, and we spin the wheel again. Yeah, 5 by 8 plus 4 times 6. 64? Okay, super. All right, and then we want to do 5 times 8 plus 4 times 10. 80. All right. And then I need to do 5 times 8 plus 4 times 12. 84? Right?
The next one's 85.
I know.
The next one.
I didn't eat my Wheaties. I ate ravioli instead. All right. It was good, though. Okay, 5 times 7 plus 4 times 11. 35 plus 44. 79? 35 plus 44, 79. Okay, and then,
What's 79 minus 12?
don't worry about it. And then 5 times 7 plus 4 times 9. So 35 plus 36, 71? Is that right? Okay. Hey, we're almost there. They said it couldn't be done. So stupid. I love it. I think this is great. I think this is awesome. This is so good.
Emmett, what did you get on your matrices test?
I got a 47.
Ooh, man. You know what that means? We need some redemption, Emmett. That's what that means. All right, so 1 by 8 plus 2 by 6. We're not making a lot of pants here. 8 plus 12. 20? Does that sound good? All right. Okay, 1 by 8 plus 2 by 10. 28. Great. All right. 1 by 8 plus 2 by 12. You said what? Okay. I trust you more than I trust myself on that. And then 1 by 7 plus 2 times 11. 29. Last but not least. Brother. 1 times 7 plus 2 times 9.
You could do it.
25. Yeah, okay. Math is hard, man. I don't know. Okay, cool. What does the element of 36 mean? So 36 was here. Okay? So what does that mean? Michael?
It's the number of shirts that could be made on Monday.
Yes. Why?
Because you add machine 1 and machine 2 together.
Yeah. So it's the number of shirts that are made on a Monday. So for me to assign value, I look at my rows and then my columns. I'm looking at shirts on a Monday. So that's what we're going to have. So 36 shirts are produced between the two machines. On a Monday. Yay. We feel all right? Okay. Uno mas?
Yes.
Let's see what the last one's got in store for us. Hey, if we take your grades and we put them in a matrix, it's going to look something like this. So grades for students A, B, C, D, and E are stored in matrix, these 5 students. Test 1, 2, and 4 are each worth 15% of the final grade. Tests 3 and 5 are worth 25 and 30% respectively. Use matrix multiplication to find the final average for each student. Did I say it again? Hopefully I didn't.
You're at 4 right now.
Am I at 4? 4's not that bad, honestly. Like,
4%
Well,
curve
each of it
though?
counts for like 10.
Have we ever gotten a curve in this class?
Is it percent?
So then like, that turns into what?
Oh, yeah, point.
a lot.
90
Points?
into
I'm
a-
going to make the next test worth 4,000 points. All right. 1, 2, and 4 are worth 15% of the final grade. 3 and 5 are worth 25 and 30% respectively. Matrix multiplication to find the final average for each student. Okay, so the dimensions of our matrix, of course, are 5 by 5. I need to build a new matrix, okay, that has these values in there, so that way I can find the average of my student fairly easily. How should I build that matrix? 5 by 1. So if I do a 5 by 1, what's that going to look like? Right? 5 rows, 1 column. Okay, and then the values you want to put in are 0.15. Test is also 0.1. Test 2 is 0.15. And then test 3 is 0.25. And then test 4 was 0.15. And then test 5 is 0.30. Okay. And then it says use matrix multiplication to find the final average for each student. Okay. All right, now, when I do matrix multiplication, let's think about what that looks like here. Because if I do that, I would have to do rows by columns, right? So row by column. So I would go from left to right and then top to bottom. But what would that tell me? Yeah, that'd be like some of the weighted grades, right? Because I'm just taking all of the test 1 grades and then multiplying it by each one of these weights. That's not really going to tell me anything, right? Essentially what I want to do is I want to take like the values of the test for each kid and then multiply it by my resulting matrix to figure out what my average is. So I really want to work from top to bottom here, and then I would want to work from, well, shoot, I'd have to build this matrix differently, right? So I'd have to make it a 1 by 5, but it wouldn't make sense for me to put it afterwards, right? Because I wouldn't be able to do a 5 by 1 by a 1 by 5. So I should then put my matrix to the left. I could think about it that way. So if I put the 1 by 5 to the left, then my inner matrices match, and I can have a value that's actually going to work for me. Okay, so then in that case, 0.15. Oh, no, I can't do it in crayon. Crayon's too thick. Okay, so what do we say? 1, 5, 0.15. 3 was worth 25%. 0.25. I know you guys are sighing because you've been waiting for this moment for so long, and now it's finally here. And it's just a sigh of relief, right? That's what we're, yeah, okay. All All right. So let's figure out the average for each one of our kids. So then if it's a 1 by 5 that we're multiplying by a 5 by 5, our resulting matrix is going to be what? A 1 by 5, right? Okay. Which is 1 row, 5 columns. Oh, no. I got a little carried away there. So 1 row and then 5 columns. Okay. And then that'll give me the average for student A, B, C, D, and E. Okay. Woof. All right, so I need to take these values, so from left to right, and I need to multiply top to bottom. You guys got your calculators? Unsheath those bad Larrys and let's start multiplying. Andy's ready.
Mine's like right there. My walker's right there.
That's all right. Hannah's got a bunch next to her that she can distribute if you really need one.
It's really by Mr. Guest.
Isabel, by the time you get back, I'll be done. All right, so we've got to do 0.15 times 82 plus, do I even have a calculator? I do.
I'll just do it all.
All right, 0.15 times 82 plus 0.15 times 85 plus 0.25 times what? 78 plus 0.15 times 74 plus 0.3 times 84. Okay, I got about 80.85. All right, Colin got that too. Colin, what color is your calculator?
Black.
All right, 80.85. Did what?
0.25%.
I did. It did. Okay, so now we got to do it again. Okay, so now we got to change all of our test grades. I'm just going to go second enter and then just change all of my values. So then this case, we got a 92. We got 88. We got 95. Oh, man, this kid was good. And then we got 85. Slipped a little bit there. But, hey, they picked it up for the final, 94. Okay. I got a 91.7 for the next one. Okay. I have a feeling I'm going to run out of room. Okay. Let's do, no, we're not going to stop. We got to keep going. We must soldier on. All right. So then let's do C. These kids deserve to know their averages. All right.
Can we add like to the mix for bonus?
Find their averages.
68.
We need to have like a.
Thank God for progress book, man. I'd be lost.
You know like those jars that kids have for their brain?
The swear jar?
Yeah,
Swear jar?
We should get an jar.
An jar.
Wait, can we do like every time Mr. Pacifico breathes, we get like a bottle?
I will come in with an oxygen tank.
And like the amount of times you do it, you have to put that many.
Okay, we're on the fourth one now. Is anyone doing this along with me? Like actually doing it along with it? No. Okay, all right. Andy. I can always count on Andy. All right. He is the man. All right. And then 92, 100. Whoa! Uh-oh, that threw off my whole algorithm here. Second, insert, plus. Those darn hundreds. Okay. And then 0.25 times 91. And then 0.15 times 84. And then 0.3 times 93. Okay. 92.05. It's top student so far. All right, una más. 88. 90. Delete. 92. 94. Ooh, they really had a surge there at the end of the year. 96. Okay. 92.6. Who would have thought? Student E. Can I just give you guys a letter of the alphabet and then refer to that, you as that from now on? That would be very efficient for me.
So none of them got like actual A's.
Nah. Hold on, what is it here? Because I have to enter your grades tonight. 93 is an A? An A minus, right?
No, 90 is an A.
90 is an A minus.
93 is an A.
You should
Okay.
You should give us all 90.
Stop it. No. Okay.
Yeah, we don't do A plus. We don't have A pluses.
That was the same as.
Are they not weighted differently? A pluses? Are A plus? Are they weighted more?
We don't have an A plus.
For real life?
For real life.
Did you have an A plus?
That's so sad.
Interesting.
Is this like A pluses?
You guys are so weird. All right, your homework. I made a homework slide. There it is.